Hello, welcome to lesson 3 over similar polygons. I hope you guys had a great day today so far, and I hope you thoroughly enjoy this lesson on similar polygons. So let's start. Go to you're looking at page 8 in your Unit 2 packets, and we are going to start with a couple of definitions. So let's just look at if you have two polygons that are, we're going to be talking about similar. So two polygons that are similar. If corresponding angles are congruent and corresponding side lengths are proportional. That's how we know that two polygons are similar, is if they have those two things, and hopefully you discovered that through your investigation of those triangles that you have done in class. So in this picture we have ABCD, which is just the name of that quadrilateral right there in red, is similar to EFGH. And we're going to list out our corresponding angles and our ratios of our corresponding sides. So you have this in your packets, make sure you write it down. So first of all, if I know that ABCD is similar to EFGH, I have a special symbol that I use for that. We say ABCD is similar to EFGH. And I'm going to zoom in a little bit on this so I make sure that my handwriting doesn't get too wonky on you. And so we're looking at this polygon in red, and we're looking for the corresponding angles. So I'm going to use that congruence statement, and it's not really a congruent statement here, it's a similarity statement, and I can see that A is going to be congruent to E. Okay, so since they're similar polygons, their corresponding angles are congruent. So angle A is congruent to angle E. All right, so then B would have to be congruent to F. So angle B is congruent to angle F, and angle C is congruent to angle G. And I'm just going right down that similarity statement. D is then congruent to H. So I've listed out all of my corresponding angles. Now, the ratios of the corresponding sides should all be equal to each other, and we'll get a word for that here in a minute. But the similar sides you can also get from that similarity statement. And basically what we're looking at here is we want to know AB corresponds to what? So it's EF right here. We can see that. If you just underline those first two, AB corresponds to EF. So that means that the ratio of AB to EF should equal the ratio of the other corresponding sides. So AB over EF. And then let's look at, we have BC and FG. So BC over FG. And then we have CD and GH, so CD over GH. And lastly, we have A and D, so AD over EH. You can use your picture on this one because your similar polygons are facing the same direction. So we can see like this side right here corresponds to this side right here, and BC right here corresponds to this side right here. But they're not always facing the same direction. So remember, use those similarity statements. They are there to help you. Zoom back out on that. All right, so let's look at example 1 here. In example 1, we have a diagram, and once again, these are facing the same direction. They're lined up really nicely for us, but we also have this beautiful similarity statement. Triangle RST is similar to triangle XYZ. So we want to check that the ratios of the corresponding side lengths are equal. So in order to do that, I'm just going to look at RT and XZ, and we can check that in our similarity statement and make sure that those are in fact corresponding, and they are. So 25 over 15, I'm going to mark what I'm doing there. I'm doing RT and XZ, and that equals 25 over 15, which if you simplify, and you can do that on your calculator, or you can look to see what number both are divisible by, it simplifies to 5/3. So then let's look at our next one. We have TS to ZY, and TS is 30 and ZY is 18, and those are both reducible by 6. 6 goes into 35 times and into 18 3 times. And then lastly but not least, we have RS and XY. So RS to XY equals 20 to 12, which then both numbers are divisible by 4. 4 goes into 25 times, and into 12 3 times. So they are proportionally, they're all equal there. Our ratios corresponding to the side lengths are all equal. So that's great news. That means that they are, in fact, similar. That's what we mean here of ratios of corresponding sides being proportional. So let's go ahead and look at the next part on your notes. Definition. If two polygons are similar, then the ratio of the side lengths of the corresponding sides is called the scale factor. We've mentioned that word in class. In example number 1, the common ratio of 5/3 is the scale factor of triangle RST to triangle XYZ. And you have to be really clear what you're doing there. You're going from RST to XYZ. So make sure that you always know which one you're starting with there. So example 2, we're going to determine whether the polygons are similar, and if they are, we're going to write a similarity statement and find the scale factor of FGHJ to ZYXW. So first of all, let's go ahead and identify the pairs of congruent angles. We have angle F is congruent to angle Z, and we just know that by that one arch. We have angle J is congruent to angle W. We can see they're both right angles. We have angle X is congruent to angle H. I'm going to be consistent with how I'm naming that. And angle G is congruent to angle Y. So there's our there's our pairs of congruent angles. Now we're going to determine whether the corresponding side lengths are proportional. So we have FJ is corresponding to ZW, and we can see that from our picture, and we can also see it from our similarity statement. FJ is 16 and ZW is 20, which simplifies to 4/5. We have JH to WX, which equals 12 to 15, which simplifies to 4/5, because I divided both by 3. We have GH to YX, which is 24 to 30. 6 goes into 24 4 times and into 35 times. And finally, we have FG to ZY, and we have 20 to 25, which also simplifies to 4/5. So since all of those corresponding sides, since all of their ratios are equal to each other, that means that they are similar. All of our angles are congruent, so we meet both of those criteria. So our similarity statement, since it is a quadrilateral, we're just going to say FGHJ is similar, that means similar, to ZYXW. And our scale factor is this guy right here, 4/5. Notice how it's the same on all 4 of those. So that's great. All right.